there, math analyzers. Welcome to your Chapter 6, Lesson 10 notes. We are going to graph systems of equations. And fortunately or unfortunately for us, whichever it may be, now that we're in Algebra 2, it's not just two lines on the same graph, and it's not just a parabola and line on the same graph. It might be a line and absolute value, or a line and quadratics, or a line and a circle, or the biggie, the one that I love, a quadratic and a circle, right, on the same graph. So, very quick review of lines and absolute value and quadratic functions and circles, which, as we know, are not functions, they are relations because, repeated x value, right? Yeah, you have to be able to know what type of thing you're looking at based on its equation. A circle will be fairly obvious in that there'll also be a y squared. And this, of course, is the circle equation with a center. You pull the center out of these two values, opposite signs, and you take the square root of this value, and that gives you your radius. So that one will be pretty obvious when you get to that. Basically, what we're going to do is we're just going to put them on the graph, look for how many intersection points there are, label everything. Let's get some colors out, right? I know you all want to see me use purple. Ain't going to happen today. We'll see. Maybe. Get my colors out. Let's see. What colors can we do for this one? Exercise 1. Oh, let's see. Look at your equations first and determine what you have. So I'm looking at a parabola, and it is a smiley face parabola because my x squared is positive, and a line. Oh, you know what? If you guys want me to do purple, let's do this. A line in blue, right? And I know that based on their equations. This one has an x squared and a y to the first power. This one has x to the first and a y, right? So let's plug the parabola into our graphing calculator right here. Why not? Oh, that's not what I wanted. This is. I want to see a big screen. Y equals, ooh, I have some parabolas already in there. Must have been from the vertex form lesson. X squared plus 2x plus 1. Let's look at it on the graph. Oh, okay. Let's get its points. Second and graph for points. Nice. Obviously won't be able to fit this negative 625 or this negative 516, but negative 49 all the way through 29 will fit on my 10 by 10 grid right here. So since I did that one in red, let's get those points right here for my parabola. Negative 49 is where I said I start. All the way to 29, right? And then, of course, 4s, 1s, 0. So this point here is the vertex, and x equals negative 1 is the axis of symmetry. And then this is also the one real root based on this particular discriminant and where we go, not crossing the x-axis, but just touching it and then going back. Yep, let's graph that. Let me get my graphing calculator out of the way so you can watch me graph it. Okay. 1, 2, 3, 4, up 9, negative 3, 1, 2, 3, 4, negative 2, positive 1, and there it is, that axis of symmetry, then turning point, and it's also the root. It's got all sorts of things going on at the same time. And arrow right at the last point I can fit. And arrow right at the last point I can fit. And I'm going to hold off on the equation until I get this line on here. Make sure the line's in y equals mx plus b form. The slope, of course, being the number in front of the x and the y-intercept being the constant. So I start at 0, 5, 1, 2, 3, 4, 5, and my slope is up to right 1. So I can see I've got an intersection point right there. Can't fit any more up to and right ones. So back to the y-intercept and down to left 1, down to left 1, another intersection point. There we go. Straight edge. Arrows at the ends. Now I can see two intersection points and I can start labeling, right? So y equals 2x plus 5 is the equation of the line. Y equals x squared plus 2x plus 1 is the equation of the parabola. Oh, I dropped the purple pen. Some of you are going to think I did that on purpose. Circle and label intersection points. This is 2, 9, and this one is -2, +1. Those are my answers. Said to solve graphically. Put them both on the graph. That's where they intersected. That is the answer to these two equations being graphed at the same time. So I'm going to put this here, and I'm just going to pull this out again. And in my y equals, I know I did the colors opposite here. I can change that. There we go. Now this one's going to be red. Narrow down here and press enter and make this one blue. Oops, blue is this direction. Okay, and this will be my line. So there you go. So my line is going to be blue for you. And then they'll match up correctly. And so put them both in here, and if you look, there we are, right? Same looking graph. Want to check these points? So second and graph gets me both tables. And remember, where your x value yields the same y value, that's an intersection point. So -2, 1, just like we have, and +2, +9, just like we have. That's your answers. What you want to kind of think about as you are given a problem and told to graph it, and think first about what types of things are going on the graph, you want to be thinking about how many intersection points those two things on the graph would have. Okay? How many are possible, right? So in this case, there were 2 intersection points and 2 intersection points were possible. Here are your scenarios, right? So I kind of put them all in your notes for you. If you have 2 lines on the same graph, the most number that they can intersect is once. You might end up with 2 parallel lines, so there's no solutions at all. You could end up with those 2 lines being exactly the same line once in y equals mx plus b form. So it's an infinite number of solutions. That really doesn't happen. I mean, if I'm testing systems of equations, I want them to intersect, right? So what we just had was a quadratic linear system. Again, back from algebra 1, but there's 3 scenarios. They don't intersect at all. They intersect once. They intersect twice. Again, probably going to be looking for these two because I want a system to actually intersect, because I want you to tell me that the intersection point is the answer. Now a circle, similar, because a circle does have an x squared involved. So if you're going with a circle and a line, so a linear circular system of equations, then we're talking about 1, none, or 2. Okay. Now this is the one, and I love these. This is the one, the big one. So parabola could have 0 intersection points. Parabola and circle, 0 intersection points. The parabola is way too high, the circle is way too low, or vice versa. Not going to happen, just not going to intersect. Or intersect 4 times, or 3 times, or 2 times, or once. So lots of options there. Okay, lots of options there when you have parabola and a circle. And boy, I'm hoping we graph one of those together. Let's graph one of those together. Exercise 3, parabola and circle. Okay, I'll get to that. Let me do this one first. I'll do exercise 2 first. I'll go in order, even though I'm really excited to see the parabola and circle together. What do I have on exercise 2? What do those bars indicate? Absolute value. And how about this guy? Another line. So we'll do those. All right. Absolute value, I can go, this is vertex form, right? So I know what the vertex is. It is opposite sign of what's inside the parentheses, so +1, correct sign of what's outside the parentheses. And my slope, or a value in this case, is -2/1. So it just means from 1, 3, right here. On the right-hand side, go down 2 and right 1, down 2 and right 1. This is going to be one side of my V shape for absolute value. Absolute values always form an A or a V. And in this case, since it's upside down, I suppose I should have said A shape. See, now I go opposite on the other side. Okay, so the right-hand side is the one that the slope gives me, the right-hand side of the vertex. And then since it's 2 lines on each side, use my straight edge, cover the whole graph, arrows at the end. I will wait to put my equation on there once I get the other line on. So let's see, this has a slope of 2/1, and a b value of -3. So that means I start down here at 1, 2, 3. And then I go up 2, right 1, up 2, right 1, 2, right 1. I see one intersection point. Let's think about that. Going to see more than one intersection point? Down 2 right 1, or down 2 left 1 to go this direction. No. Look, because of where my line heads this way, now I've got a parallel situation. So we're never going to meet again down this side. This side is my only intersection point. Right there. 1, 2, 1. Just like that. And let me label. Y equals 2x minus 3, and y equals -2, absolute value of x minus 1 plus 3. So if you're unsure where I got any of those points from for the absolute value, use your graphing calculator again, right? Let me pull this over, pull my graphing calculator back out. Use your graphing calculator to get those points. Why not? Go up to y equals, get rid of these guys because we're done with them. Y equals, I can make this gold. Yellow, yeah, baby, yellow. Okay, make it yellow. Oops, wanted this. There we go, thank you. -2, so the little negative under 3, then 2. Absolute value is under math, arrow right to number, and ABS is the first thing. So now we've got x minus 1 in the absolute value bars, arrow right to get out of them and put your plus 3, and then arrow down for your 2x minus 3, and graph them. Same thing I have, right? Same thing I have going on, okay? We have this side parallel, okay? So no more intersection points will happen. That's the 1 because we hit the vertex and then headed back down. So there it is. Nice. Okay. If you want to make sure that one intersection point is the only one, second in graph. Oh, to see the yellow more clearly. I was like, why is that shaded? But to see the yellow more clearly. We think it's 2, 1. Let's look. Yep. That is the only spot. Look at all the rest of those y values. Not the same for those matching x values. This is the one and only place where they are the same. That's it. That's the one intersection point. you can actually graph a circle in your graphing calculator, and I will show you how to do it. It's not easy, but I'll show you anyway. Um, let's get this in here first. So let me get rid of these guys. Do I want to do yellow again? Yellow and red for orange. No, let's do blue and dark green to create a light green. Huh? Yeah, let's do that. I want to see my colors a little bit better, that's all. Okay, so let's do that. Let's do the circle in the dark green. Circle. Where my vertex is 5, 3, because opposite sign of what's inside the parentheses. My radius is the square root of the number on this side. So the square root of 9 is 3. So that means go to 5, 3. 1, 2, 3, 4, 5. And then up 1, 2, 3. Now, on each side of the circle, I count out 3 for my radius. So outright 1, 2, 3. Up 1, 2, 3. Left 1, 2, 3. Down 1, 2, 3. Okay. I'm going to use my, guess I'm not going to use it because it's not here. I was going to use my compass, but I guess my compass is an MIA. I must have let someone borrow it. So, all right, here we go. Do our best. Get a circular motion in here. Freehand circle is tough. That's why I was really hoping for my compass, but that's all right. I'll survive. Yuck. Yuck. There's my circle. Parabola. So the other guy is a parabola, smiley face parabola. Smiley face parabola. And let's see. Ooh. How about I plug that into my graphing calculator to get the points for it? Arrow right, and let's change. Well, you know what? I'm just going to do it down here in Y2 where I've already got blue. So x squared minus 10x plus 19. Okay. Let me press graph to see it. Beautiful smiley face parabola. Look how pretty. Such a pretty parabola. Second end graph is where I'm going to get my points from. And 019 ain't going to fit, but 110 all the way to 910. Okay. One, 10, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's see what we got in between. 2, 3, and 8, 3, and 3, -2, and 7, -2. Oh, so you know what? The roots on this aren't going to be integer roots. Right? The roots on this aren't integer roots because there's no y0 as one of my integer points that I'm sticking on this. I can see that my axis of symmetry is x equals 5, and my vertex, which of course is a minimum vertex, is 5, -6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6 down here. And then I got stuff on each side, right? Stuff on each side. 1, 2, 3. 1, 2, 3, 4, 5. Oh, look at that. Those points hit on the circle. And then what do we have after that? So 110 all the way up here. And connect. I drew that out a little bit, so I'm thinking one intersection point there and one intersection. Oops. Jeez, sorry about that. One intersection point there. Arrows at the last points I can fit for this parabola. Yeah, that works. 1, 2, 1, 2, 3. So 2, 3, and 3, 4, 5, 6, 7, 8, 3. Let's get labels. Oh, f of x, excuse me. Circle label, it's over here. X minus 5 squared plus y plus, excuse me, minus 3 squared equals 9. I got my labels on there. Let's get the circle in the graphing calculator. And so I'll kind of show you where to do that. Green is back this way. So first thing you do when it comes to a circle, getting a circle on your graphing calculator is you want to have your y alone to be able to put it in here. Well, what that means is you'll have to move your whole x binomial over to the other side of the equal sign behind the radius. Okay, so I'm just going to rewrite the whole thing because we're trying to get this y alone, but it's stuck under the square. So what we do here is we start by subtracting this entire binomial squared from both sides of the equal sign to move it away from the y squared that's there. Now you've got y minus 3 in parentheses squared equals 9 minus x minus 5 in parentheses squared. Well, remember, I don't need to know. I'm just trying to get y alone. So don't worry about the other stuff that's going on. Just represent it. So now the opposite of squaring something is taking a square root. And that means this cancels out and leaves you with y minus 3 equals plus and minus the square root of all this. It's all under the radical. Don't worry about it because we're just going to enter it into our graphing calculator, right? But the last thing we need to do is move this 3 over by adding it to the other side. And it, of course, goes in front of the plus or minus. So this is two separate pieces that I'm going to put into my graphing calculator. So in one of my y's, I'm going to put 3 plus or minus radical 9 minus x minus 5 squared. And in the other side, not plus or minus, I'm just plus. I don't have a plus or minus button on my graphing calculator. Duh. That's why I'm showing you this. And 3 minus the square root of 9 minus x minus 5 in parentheses squared. These separate things go in your y equal. So let me show you in y equals 1, I'm going to put 3 plus the square root, there it is, of 9 minus front parenthesis x minus 5 end parenthesis square root or squared, done. There it is. Then gonna head down to y3 because that's my next open one. Gotta change it to green. Right? And now it's gonna be 3 minus the square root of 9 minus front parenthesis x minus 5 end parenthesis squared. Done. Now if I press graph, you're going to see the two halves forming that circle that, of course, is inside this parabola where it is. And so then you can see when you press second and graph, intersection points. Now remember, so 2, 3 is an intersection point as we already knew, and 8, 3 is an intersection point as we already knew. Remember, these are going to show arrows, those semicircles that we just graphed. They're going to show errors in the places where there are no x values being used because it's a circle. Okay, so they're going to show those errors. Let me just show you the graph again. See, outside of that, so because the radius is 3 and it's right there, outside of that is going to show no points for your semicircles. That's why you're going to get errors on each side. Okay, so this is where we can see any intersection points, just like we have. So we can use our graphing calculator to double check for those. That's it. Put these suckers on the graph, label it all. Label the equations of the function or relation that you are putting on the graph. Label and circle the intersection points so we know that you know those are the answers. That's all you need to be doing for that. Okay? Just keep practicing putting things on the graph and remember to keep in mind how many potential intersection points you could be getting. You know, we got this one just now with the circle and the parabola, right? You can get something like that. But make sure you consider what types of functions you're graphing as you go. Okay? Got to be able to recognize the different types of functions or relations based on their equation. Then you know what you're putting on the graph. Alrighty, guys, good luck. Have fun doing the practices. I will be seeing you soon. One last lesson in chapter 6 before we start getting ready for our test. Okay, bye, guys.